Now we have completed design part of a shaft. Now we are going to see the example based on which this design procedure can be understand very easily. Okay, so numericals on shaft. So first, to understand it very easily, for any unit you can do this thing. Just create one sheet where all types of formulas you can write it down so that it will be easy to understand. Here the power and torque formula is written, then torque transmitted by the pulley is written, then tangential force by gear, then load acting on gear. This is the twisting moment of shaft for solid shaft, for hollow shaft, for bending movement also. In the same way, for equivalent twisting movement, then equivalent bending movement. So according to ASME code, KMKT and all these things I have put it here only. You can do in the same manner so that you will be able to solve any type of numerical very easily. Now this is the problems here. Here a shaft is there which is supported at the ends in ball bearing carrying a straight tooth spur gear at its mid span and is to transmit 7.5 kilowatt at 300 rpm. And the pitch circle diameter of the gear is 150 mm. The distance between the center line of bearing and the gear is 100 mm each. So all these things are given here. Shear stress is also given to us, that is 45 megapascal, and diameter of the shaft we need to determine here. So let's see what given data I have written down this given data here. Okay, so all given data is written here. Now a figure is shown here. This is the figure. This is the bearing. The bearing distance between two bearings is 200 mm. It is shown here where it is gone. Okay, of gear and 100 mm each from this to this 100 mm. So total distance 200 mm. Total pitch circle diameter of gear is 150 mm. This is the shaft and this is the gear. Like this, it is shown here. Now torque transmitted by the shaft is what? T is equal to P into 60 by 2 pi m. We get the torque value here. Same thing, we need to find out the force which is acting on the gear because that force is acting on the shaft. Force 2T by D is the formula. Torque T is the torque. We have put it, we get the values in Newton. Now this force will convert in the load now because it's a angular force. So this angular force, that is tangential force, is converted into load with the help of this formula. And cos of alpha, pressure angle is 20 degree, so that's why we have taken alpha as 20 degree. So we get a total load as 3387. This is the vertical load which is acting on the shaft. So based on this, it is the middle shaft, that's why MWL by 4, a beam formula we have seen. So bending moment is known to us now. So equivalent twisting moment we have T is equal to square root of M square plus T square. We have the value of M, and in the previous slide we already get the value of T. Put that value and you will get a TE. So TE we have for T is equal to pi by 16 tau dq. We put the values here and just get the value of D. So now solving this, we get D is equal to 32 mm. We can say that 35 mm. So this is the diameter of the shaft. Okay, I hope you understand this part very easily. It's a very simple numerical. In the next, we are going to see some difficult type of numerical also. Thank you.